this is Professor Cummings, and you have completed modules 1 through 5 at this point, or at least you should have. And now I'm giving you your introduction into module 5 in Lean Six Sigma. Now, just to review, go over a few of the details that we've discussed before. In module 1, that was just an overview of Lean, of Six Sigma, and how Lean Six Sigma work together so that we can get the customer a better product, as well as things like a better organization, eliminating waste, cutting down on variation. It gave a definition of Lean, of the Six Sigma, and some of the key terms. In module 2, we discussed what the different roles and goals of each of the particular people that are going to be involved in Lean Six Sigma and how they were going to work together. So we discussed what a black belt is, what a green belt is, and what their obligations are, what the purpose of a cross-functional team is, as well as when they get together, what are they trying to actually accomplish, as well as how you actually implement Lean Six Sigma into an organization. We had a case study and we went through a few different examples and defined more terms. In module 3, we took that same group, the cross-functional team, the black belt and the green belt, and introduced the idea of the voice of the customer, as well as value stream mapping, and discussed the method or the general idea of establishing a current state. In other words, using all of these tools to understand where your process was at this given moment, as well as how this ties in with introducing the organization to the whole concept of Lean Six Sigma and all the principles that you're going to be working with. So at the end of module 3, you could see, or hopefully you could see, how this whole cross-functional team was going to get together and how they had an actual goal and an agenda for how they were going to help their organization. So it wasn't just a matter of throwing a bunch of tools or a bunch of solutions at a problem, but there's actually a way of establishing a baseline and how the team actually moves forward. Then in module 4, we actually looked at some of the actual tools that take place that actually tie Lean into Lean Six Sigma. So we looked at, module 3 as far as how everything gets prioritized. Module 4 is actually showing how the team is actually using specific tools to deal with waste. So streamlining the process and actually getting rid of different things that are actually going to cause the customer to have non-value added cost or non-value added activity inside the process. So you're basically looking at various tools that you're using to get a lean outcome. Now, let's think about our example that we went through in a past module. It was we discussed a company called Cullen/Blow. They made this cereal that was actually apparently successful enough, but we were having an issue with the weight of the boxes. All right, so we expected the boxes to be 16 ounces, but we were seeing variation that went outside of what the customer actually expected, what the customer actually deemed acceptable. And when we did this, we went through and actually discovered that that variability, how big that variation was, and what this meant in implication to what the customers actually expected. And we saw that when we did this, when we laid out the numbers and actually saw how this operated on a larger scale of 1 million units of boxes, or 1 million boxes going out to the customer, we saw that we were nowhere near reaching Six Sigma. As a matter of fact, we were actually operating at a 2 Sigma level. Now, the whole idea of Six Sigma in that discussion, and using this discussion with Cullen/Blow, was actually showing the implications of Six Sigma and how it's actually applied. So basically, why Six Sigma is called Six Sigma, and Sigma being the standard deviation. So what we actually realized was when you have established criteria, in this case, Cullen/Blow had 16 ounce boxes they were trying to meet, plus or minus 1.2 ounces. The customer would have considered 14.8 to 17.2 acceptable. And if they were able to operate within Six Sigma, that we would have actually had 99.9997% of the product falling within specification. Now instead, what we had seen was that 24 out of 72 boxes were actually defective. Which essentially is 1/3 of the boxes were coming in outside of that range, outside of that window of 14.8 to 17.2. So what that meant was, when we looked, did a little bit of math, that for every 1 million boxes, 333,000 were actually not acceptable boxes as far as our customers were concerned. Considering this is what the customer actually expected, 16 ounces plus or minus 1.2 ounces. That's what the voice of the customer was telling us. So we were failing the voice of the customer at least 1/3 of the time. Now, that defined Six Sigma. That actually gave an idea of what Six Sigma looked like and what it actually meant. Taking it away from just a name and actually applying a few numbers to it, we could actually see this is what people are looking at Six Sigma, and hopefully that illustrated the benefit of Six Sigma. But Six Sigma isn't just about pointing out problems. It's actually about addressing problems. So the question comes up is, how can Kohlenblow address the problem in variation in their process? We can see that it's clearly a variation issue. If you go back to that particular video, you'll see the mean that we found when we did our little sample was actually 16 ounces. It actually hit the average roughly at 16 ounces. We just had a spread or a standard deviation that was entirely too wide, entirely too large for what the customer actually considered acceptable. So the problem was variation. So we knew that we had a problem with variation. In some instances, it would be variation as well as getting the mean, but in this case, we were lucky we just had variation. So we minimized something in our as far as problems we have to solve. So a way to address this, we're going to have to deal with the cross-functional team, the green belt, as well as establishing a value stream map. But we've looked at those in past modules. We know that that's one of the first steps we're going to have to do when dealing with a large process like this. We've also understand that there are several types of tools that we can use as far as why the problem might take place. Fishbone diagram, control charts. Those are all good sources of information to keep this thing a data-driven process. We also can go through the process and look at different types of waste that we're having, overproduction, underproduction. This would actually be considered a different type of waste, but as far as streamlining the process, we could apply lean tools, but that doesn't address this core problem of variation, not necessarily. So what are we going to do? How will Kohlenblow actually address that? Well, there is something else that we can talk about here that is a very effective problem-solving strategy for continuous improvement. It's based off of the scientific method, and it's known as the DMAIC process. The DMAIC process is one of the first things people think of when they think of Six Sigma. It's addresses the variation. It's a problem-solving tool. Like I said, it's based off of the scientific method. And what it stands for, each one of the letters in DMAIC actually gives you a step in this problem-solving strategy. It goes from define the problem, measure the problem, analyze the problem, then come up with some type of an improvement for the problem. And then, much like the scientific method, that means you're actually going to observe and control the problem. And if all else fails, then you're going back into a circuit mode, much like the scientific method, back to define the problem. So that is what we're going to be going in this last module. This is module 5. We're going to be going through the DMAIC process and showing how it applies to actual problem solving. So I look forward to you in this last chapter, and we can go through a discussion. And again, I want to thank you for taking this particular course, and we'll talk again later.